Yeah, today we want to talk about strong column, weak beam. So, how this relationship between columns and beams is, and how it actually affects a structure, when you're on site. So, you have collapse mechanism comparison. So, we are going to use collapse mechanism comparison method to actually check how columns and beams interact. So the goal is a ductile mechanism with beam yielding before the column. If you want to consider your elastic limit where you have your yield point, so we want to know when a beam is yielding, before the columns. So the first one, we have weak column, strong beam, and you can see how the deflection is. We have brittle collapse, then undesirable. Then we now have strong column, weak beam. So you can see ductile collapse, which is still to an extent desirable. So the design for strong column and weak beam to ensure ductile behavior and save lives. So you can actually do this sometimes intentionally in construction. Yeah, on the second slide, we'll be talking about why does this concept exist. So why do we actually have this concept? So protect the structure, protect lives. So the concept is actually to protect the structure, that is the structure you've constructed or the one you are constructing, and also to protect lives. Then we have the first one, ductile behavior. So ductile behavior ensures beams yield first, forming plastic hinge while columns remain elastic. So your beam tends to yield first. So beam is the point of consideration here. So the beam tends to yield first, forming plastic hinge, at the corners, that is the edges where it is connected to the column, while the column remain elastic. So the second point is prevent story collapse. So in a frame structure, you understand, where you have multiple beams, multiple columns, right? So it actually prevents the story from collapse. So avoid weak columns failing first, which can lead to sudden and brittle collapse. So it helps to avoid the weak columns from failing first, and it always leads to a brittle collapse. Then provide warning. So beam yielding causes visible damage, giving occupants time to evacuate. So and you can actually see this on buildings. So these cracks actually makes that provision for you to be able to, evacuate the building as soon as possible when you start seeing all these cracks. So it's a possible sign of collapse. Then the next point is meet code intent. Every code has its intent. It has a reason of generating such code in construction. So it is a core principle in seismic design codes worldwide. Then strong columns and weak beams, will always result to a controlled, ductile, and long life-saving response. So strong columns and weak beams, will always result to a controlled, ductile, and life-saving response. So when you have such a combination of strong columns and weak beam, it actually helps to see when the structure is about to fail, and it gives you that time to be able to evacuate such kind of a structure, a building. What we have here in the next slide is common mistakes that breaks the concept. So in as much as you are looking at strong column, weak beams, there are other mistakes that tend to break, that disseminates the whole concept, that puts the whole concept into a void. So, and the first one is weak column. You can see some part of the column is strong, but the section of the column that is to the foundation is weak, and you can see where the failure is coming from. Brittle and dangerous collapse. So it's going to give a very brittle and dangerous collapse. Then if you have similar strength, that means the strength is uniform, right? Then you now have multiple plastic hinge on the columns. So when the columns is too strong, all the parts are too strong, you are going to have multiple plastic hinges. Then we have strong beams. When you have a strong beam and weak column, so you are going to have soft story failure. So the failure is going to come stage by stage. You understand? The first story will collapse, then the second story will also collapse, right? Then we now have mistake in hierarchy is equals to risk to life and structure. So when you are making your construction, it's very, very imperative for you to actually have this in your head so that you don't make the mistake that is going to risk the life and the entire structure itself. Yeah, here are the practical design tips. So with these tips, it helps to ensure the safety of your entire structure. So design for strong columns and weak beams. So if you want to design for your strong column and weak beam, so first you have to check strength hierarchy. So, and to check that, you're going to ensure that the summation of movement on the columns is greater or equal to 1.2 summation of the movement on the beams. So invariably is actually going to be greater than that of the beam. So, and that actually makes it okay. You understand? So at every joint, you're going to ensure that the summation of the movement on the column is going to be greater or equal to 1.2 summation of the moment on the beam. Then you're also going to use stronger columns. You understand? Large column sections, higher reinforcement. So you make sure you use high column sections. And if you are going to construct high column section, it's going to also come with higher reinforcement. Then you make sure you use weak beams. You understand? Because when you make use of weak beams, smaller sections control reinforcement. So when you make use of weak beams, you're going to also have that understanding that you're going to use controlled reinforcement. Then we have detail for ductility. Provide confinement in columns and proper anchorage. So anchorage is very, very important in your column. So you provide proper anchorage for your beams. The anchorage is coming from the beams. Then your lap length too is also meant to be considered in regards to this. Then good design isn't just about strength, it's about the right balance. So a good design is not usually about the strength, it's also about the right balance. Make sure your beams are appropriately placed, your columns are designed very well to carry the whole strength that is required, right, for the building. So final takeaway: stronger columns, weak beams, ductile response, safe structure. So this is how to do it right, and this is how to get it wrong. So ductile collapse, it's okay. Brittle collapse, it's undesirable. So these are things for you to remember. The goal is not to make everything strong. The goal is to make it fail in a safe and predictable way. So even if the structure is going to collapse, it should give people that room to evacuate the building before it tends to collapse. So that is why this type of design actually helps you, because you see the cracks on the wall from the beam section. So it shows that there's an inevitable collapse coming. So, and it helps people to be able to evacuate such kind of building before the said collapse. So strong columns, weak beams is another practice that is engaged in by engineers, which tends to help construction safe. It helps engineers to construct buildings that are safe, giving room to people to evacuate the said building before any eventuality occurs, right?